In order to solve these integrations, I will use some trigonometric identities. So there are some trigonometric identities. As we know that sine square x plus cos square x equals to 1 for all angles, okay, for all x, whether it may be 30 degree, 45 degree, any angles, because this identity is true. And we have cos of 2x is equals to cos square x minus sine square x. So from here what I can do is, from here cos square x is same as 1 minus sine square x. So instead of cos square, what I can do is I can write 1 minus sine square x minus, we have already sine square x. So minus minus plus, we have 1 minus 2 sine square x. On the left hand side, what we have cos of 2x. Now if I want to find sine square x from here, what I can do is I can send this that side. It means we have 2 sine square x equals to 1 minus cos of 2x. Now this 2 I can divide the whole side by 2. Okay. Therefore instead of sine square x, I can write 1 minus cos 2x upon 2. Okay. Instead of sine square x, I am going to write this and then integrate. So it's quite simple. This is same as integral 1 minus cos of 2x upon 2 dx is equals to half. I can send outside, it is constant, integral of 1 dx minus integral of cos of 2x dx is equals to half. Now this is same as integral and integration differentiation gets cancelled. We have x minus integration of cos 2x is sine of 2x upon, again we have to differentiate twice x with respect to x, that we have to divide. Differentiation of twice x become 2 and with some constant of integration. Okay. So this is same as, I can send half outside, this x by 2 minus 2 to the 4 sine of twice x plus c, where c is constant of integrations.